Okay, the next subtopic 7.3 period of simple harmonic motion. Okay, there is only one learning outcome in this subtopic, which is you should be able to use expression for period of SHM. Okay, expression for T for simple pendulum and single spring. So ada dua benda. Okay, the formula untuk period adalah untuk simple pendulum dan juga single spring. Okay, let's look at the first one, which is simple pendulum oscillation. Okay, di mana this one where we have a pendulum attached to a string and then it is being released. So the formula to find the period for this situation is this one. Okay, di mana T is equal to 2 pi square root of L divided by G, di mana L adalah length of the pendulum. Okay, the length of the pendulum here, and G is the value for the gravitational acceleration. Okay, so meaning that here, the period of the pendulum depends on the length of the pendulum, not the pendulum, the length of the string and the gravitational acceleration. So it doesn't depend on the mass. Okay, it doesn't depend on the mass of the pendulum. So dia tidak kisahlah pendulum tu berat dia macam mana pun, it doesn't affect the period of the pendulum lah. Okay, so this one under a condition that the angle is being released at angle less than 10 degree, which is what you have done before in the experiment 5. Okay, di mana kita release pendulum tu below than 10 degree. Okay, so this is just the derivation of the formula, tapi you don't need to know, so you just need to use this formula only untuk pendulum. Okay, next one we have for single spring oscillation, di mana we have a spring connected to a block of mass. Okay, so this one, okay, dia punya formula berbeza dengan pendulum, di mana to find the period, it is equal to 2 pi the square root of mass times mass divided by the spring constant. So this one, the period of a spring depends on two things, which is the mass of the block of the object here, and then the spring constant of the spring lah, which is spring constant. Remember before this one, they measure the stiffness of the spring. Okay, so there are two formula that we are going to use in this subtopic. Okay, next one, let's look at example 10. The length of a simple pendulum is 75 centimeter. It is released at an angle of 8 degree to the vertical. Okay, calculate the period of the oscillation, the pendulum's bob speed and acceleration when it passes through the lowest point of the swing. Okay, so first let's draw the pendulum here. So we have a pendulum which is released at an angle. So this is the pendulum. It is released at an angle of 8 degree. And then the length of the pendulum, okay, the length here is 75 centimeter. And then it is being released and it will swing back and forth. Now we want to calculate what is the period of the oscillation. Okay, so first question, we want to find what is T. So kita ada satu formula sahaja to find the period untuk pendulum, which is 2 pi the square root of L divided by G. So masukkan saja 2 pi, the length must be in SI unit, since kita punya G adalah dalam SI unit, 0.75 divided by G, 9.81. So we get the period is equal to 1.74 second. Okay, next one, we want to find the pendulum's bob speed and acceleration when it passes through the lowest point. Okay, so lowest point of the pendulum bermaksud adalah dekat equilibrium. So this is the lowest point lah, which is y sama dengan kosong. So the keyword here meaning that y sama dengan kosong. Okay, so we want to find what is the speed and what is the acceleration. Okay, so if we go back to the notes which is in the previous subtopic, okay, which is here. Okay, so at equilibrium, di mana y adalah sama dengan kosong, v will be at maximum. So bermaksud v max akan sama dengan a omega, while the acceleration will be equal to 0. So kena ingatlah this condition here. Apabila y sama dengan kosong, v will be at maximum, di mana kita akan gunakan formula ni to find v max, and then acceleration will be equal to 0. Okay, so acceleration will be equal to 0 because it passes through here. Dia ngam-ngam dekat sini, y sama dengan kosong. So the value for v will be maximum, which is equal to a omega. Okay, at y sama dengan kosong, v is at maximum. So masukkan, we haven't had the value for a and omega lagi kan. So kita tiada lagi value for amplitude and omega. Okay, macam mana kita mau cari amplitude? Okay, so since this one adalah the point where the pendulum is being released. So maksudnya ni adalah amplitude dia. Okay, point maximum dia lah sebab dia being released at this angle. So meaning that we want to find what is the value here. So we can find this value here using the Pythagoras. Okay, di mana sin theta is equal to opposite divided by hypotenuse. So opposite divided by hypotenuse. So sin kita adalah 8 degree. Opposite is the amplitude divided by hypotenuse is the length, which is 0.75. So amplitude will be equal to 0.14 meter. Okay, so the amplitude here is equal to here. And then the omega, okay, we need to find omega as well. Di mana omega adalah sama dengan 2 pi over t. So t 1.74, which is equal to 3.61 radian per second. So boleh masukkan value amplitude tadi 0.104 and then omega 3.61. So the maximum velocity is equal to 0.375 meter per second. And then acceleration is equal to 0 when y is equal to 0. Okay, so this is for example 10. Okay, next one, let's look at example 11. A pendulum makes 120 complete oscillations in 3 minutes at a location where g is equal to 9.8 meter per second squared. Find the period of the pendulum and its length. So kita mau cari dua benda, the value for t and the value for the length. Okay, so we are given the information here. 120 complete oscillation in 3 minutes. So basically this is the value for frequency. Kita tahu frequency adalah number of complete oscillation ataupun complete cycle in 1 second. Okay, but right now we are given 120 complete oscillation in 3 minutes. So frequency will be equal to 120 divided by, kita mau convert dia kepada second lah, 3 minutes, which is equivalent to 60 second. So akan dapat 2 over 3 Hz. From here we can find the period, which is 1 over f, sama dengan 1 over 2 over 3, which is equal to 1.5 second. And then we can find the value for the length, since kita sudah ada the value for period, di mana formula untuk period adalah 2 pi length divided by g. Okay, so we can find the value for the length here, since kita sudah ada value t and g is given 9.80. Okay, kalau dia bagi value tu, so kita kena gunalah value tu, which is 9.8. So the length of the pendulum is equal to 0.56 meter.